There are several problems with this scenario. Firstly, parallel neutral paths are a violation of the National Electrical Code, or NEC. In the event of a fault, current could flow through both neutral conductors, potentially overloading the neutral and causing a fire. Secondly, the loads are sharing the neutral conductor back to the switch box, resulting in unequal load distribution. The dishwasher is operating at a high current, 9.8 amps, than the disposal, 5.8 amps, which could cause the neutral conductor to overheat. The 220 ampere circuits are protected by separate circuit breakers. However, the 12/3 cable supplying the receptacle outlet is only rated for 15 amps. If both the dishwasher and disposal are operating simultaneously, the current could exceed the rating of the 12/3 cable and trip the circuit breaker. A correct way to wire this scenario would be to use two separate 12/2 cables, one for each appliance, running directly to the receptacle outlet. The neutral conductor for each circuit should be connected to the neutral terminals in the receptacle outlet, and the ground conductors should be connected to the green or bare copper ground screw. In summary, parallel neutral paths are not permitted. Load should be evenly distributed on the neutral conductor. Circuit protection should be appropriate for the conductor rating. Proper wiring practices should be followed to ensure safety and code compliance. When dealing with electrical circuits, safety is paramount. Incorrect wiring can lead to several hazards, including electrical shocks, fires, and equipment damage. In this specific scenario presented, where 220 ampere dedicated circuits power a dishwasher and the disposal through a shared neutral, several violations of electrical codes and potential dangers arise. One of the primary concerns is the creation of parallel neutral paths. The National Electrical Code, or NEC, strictly prohibits the use of parallel neutral conductors in this type of application. When multiple neutral conductors are connected in parallel, the current does not necessarily divide equally among them. This unequal distribution can lead to one neutral conductor carrying more current than it is rated for, causing it to overheat and potentially ignite surrounding materials. The imbalance is exacerbated by the fact that the dishwasher and disposal operate at different current levels. The dishwasher, drawing 9.8 amps, places a significantly higher load on the neutral conductor than the disposal, which only draws 5.8 amps. This disparity in current draw can further contribute to the overheating of the shared neutral conductor. Another critical issue is overcurrent protection. A 12/3 cable supplying the receptacle outlet is rated for only 15 amps, while the two circuits feeding into the switch box are each protected by 20 ampere circuit breakers. If both the dishwasher and disposal operate simultaneously, the combined current draw, 15.6 amps, exceeds the cable's rating. This situation creates a significant risk of overcurrent, which could damage the cable, trip the circuit breaker, or, in a worst-case scenario, start a fire. To rectify the situation and ensure a safe and code-compliant installation, several steps must be taken. Firstly, eliminate the shared neutral conductor and establish separate, dedicated neutral conductors for each circuit. This can be achieved by running two separate 12/2 cables from the switch box to the receptacle outlet, one for the dishwasher and one for the disposal. Each cable should have its own neutral conductor that is connected directly to the neutral terminal on the corresponding receptacle outlet. Secondly, verify that the overcurrent protection is appropriate for the conductor size. Since the 12/3 cable is rated for 15 amps, it should be protected by a 15 ampere circuit breaker. However, given that the dishwasher and disposal each require a 20 ampere circuit, it is more appropriate to run two separate 12/2 cables, each protected by a 20 ampere circuit breaker. This configuration ensures that each appliance has adequate power and that the circuit breakers will trip in the event of an overcurrent. Thirdly, ensure that all ground conductors are properly connected. The ground conductors in each cable should be connected to the green or bare copper ground screw on the receptacle outlet and to the grounding system in the electrical panel. This provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Proper grounding is essential for electrical safety and should never be overlooked. In summary, the initial wiring scenario presents several critical safety hazards and violates the National Electrical Code, or NEC. The use of parallel neutral paths, unequal load distribution, and inadequate overcurrent protection all contribute to an increased risk of electrical shock, fire, and equipment damage. To mitigate these risks, it is essential to eliminate the shared neutral conductor, establish separate dedicated neutral conductors for each circuit, verify that the overcurrent protection is appropriate for the conductor size, and ensure that all ground conductors are properly connected. By following these recommendations, a safe and code-compliant electrical installation can be achieved. When addressing electrical wiring, understanding the fundamentals of circuit design and safety protocols is crucial. The scenario involving a dishwasher and disposal sharing a neutral conductor highlights several key principles. Firstly, the concept of dedicated circuits is essential. Appliances like dishwashers and disposals, which typically draw a significant amount of current, should be on their own dedicated circuits. This means that each appliance has its own circuit breaker and wiring run directly from the electrical panel. Dedicated circuits prevent overloading of existing circuits and reduce the risk of voltage drops, which can damage appliances. Secondly, the neutral conductor plays a critical role in completing the electrical circuit. In a standard 120-volt circuit, the neutral conductor carries the return current back to the electrical panel. It is essential that the neutral conductor is properly sized to handle the expected current load. Sharing a neutral conductor between multiple circuits, especially when those circuits have varying loads, can lead to an imbalance in the current flow. This imbalance can cause the neutral conductor to overheat, creating a fire hazard. Thirdly, the National Electrical Code, or NEC, provides specific guidelines for electrical wiring and safety. The NEC prohibits the use of parallel neutral conductors in most residential applications. Parallel neutral conductors can lead to unequal current distribution, which can overload one or more of the neutral conductors. The NEC also specifies the minimum wire size for various circuit types and the appropriate overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the wiring from excessive current flow. If the current exceeds the rating of the circuit breaker or fuse, the device will trip, interrupting the flow of electricity and preventing damage to the wiring. In a scenario with a dishwasher and disposal, the 12/3 cable supplying the receptacle outlet is rated for only 15 amps, while the circuits feeding into the switch box are each protected by 20 ampere circuit breakers. This creates a situation where the cable could be overloaded before the circuit breakers trip. To correct this issue, the 12/3 cable should be replaced with a larger gauge cable that is rated for at least 20 amps, or two separate 12/2 cables should be used, one for each appliance. Proper wiring techniques are also essential for electrical safety. All electrical connections should be made inside approved electrical boxes. Wire connectors should be used to ensure secure and reliable connections. Wires should be properly supported and protected from physical damage. Grounding is another critical aspect of electrical safety. All electrical boxes and appliances should be properly grounded to provide a path for fault current to flow back to the electrical panel. This helps to prevent electrical shock in the event of a fault. In summary, the scenario with the dishwasher and disposal highlights several important electrical safety principles. Dedicated circuits, properly sized neutral conductors, adherence to the National Electrical Code, or NEC, appropriate overcurrent protection, and proper wiring techniques are all essential for ensuring a safe and reliable electrical installation. When working with electricity, it is always best to consult with a qualified electrician to ensure that the work is done correctly and safely. When considering electrical installations, especially those involving multiple appliances and circuits, it's crucial to adhere to established best practices and safety standards. The scenario presented, with a dishwasher and disposal sharing a neutral conductor, underscores the potential hazards and code violations that can arise from improper wiring. One of the fundamental principles of electrical wiring is to ensure that each circuit is properly balanced. A balanced circuit is one in which the current flow is evenly distributed among the conductors. When a neutral conductor is shared between multiple circuits, it can become overloaded if the loads on those circuits are not evenly distributed. In the case of the dishwasher and disposal, the dishwasher draws significantly more current than the disposal, which can lead to an imbalance in the current flow on the shared neutral conductor. This imbalance can cause the neutral conductor to overheat, creating a fire hazard. Another important consideration is the ampacity of the conductors. Ampacity is the maximum amount of current that a conductor can safely carry without overheating. The National Electrical Code, or NEC, specifies the ampacity of various types of conductors based on their size and insulation. In the scenario with the dishwasher and disposal, the 12/3 cable supplying the receptacle outlet is rated for only 15 amps, while the circuits feeding into the switch box are each protected by 20 ampere circuit breakers. This creates a situation where the cable could be overloaded before the circuit breakers trip. To address this issue, the 12/3 cable should be replaced with a larger gauge cable that is rated for at least 20 amps, or two separate 12/2 cables should be used, one for each appliance. In addition to ampacity, it's also important to consider the voltage drop in the conductors. Voltage drop is the decrease in voltage that occurs as current flows through a conductor. Excessive voltage drop can cause appliances to malfunction or operate inefficiently. The National Electrical Code, or NEC, recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, it's important to use conductors of the appropriate size and to keep the length of the circuits as short as possible. Grounding is another critical aspect of electrical safety. Grounding provides a path for fault current to flow back to the electrical panel, tripping the circuit breaker and preventing electrical shock. All electrical boxes and appliances should be properly grounded to the grounding system in the electrical panel. In addition to grounding, it's also important to use ground fault circuit interrupters, or GFCIs, in areas where there is a risk of electrical shock, such as kitchens and bathrooms. GFCIs are designed to detect even small amounts of current leakage and to trip the circuit breaker, preventing electrical shock. In summary, the scenario with the dishwasher and disposal highlights the importance of following established best practices and safety standards when installing electrical wiring. Proper circuit balancing, conductor ampacity, voltage drop, grounding, and ground fault protection are all essential for ensuring a safe and reliable electrical installation. When working with electricity, it's always best to consult with a qualified electrician to ensure that the work is done correctly and safely. The configuration described, where a dishwasher and disposal share a neutral on a multi-wire branch circuit originating from a single GAN box, presents several potential problems that warrant careful attention. These issues primarily revolve around safety, code compliance, and the potential for equipment damage. Firstly, let's address the shared neutral. While multi-wire branch circuits are permitted by the National Electrical Code, or NEC, they require careful implementation to ensure safety and proper operation. In a multi-wire branch circuit, two ungrounded, or hot, conductors share a single neutral conductor. The key is that the voltage between the two ungrounded conductors is twice the voltage between each ungrounded conductor and the neutral. For example, in a typical 120/240 volt system, the voltage between the two ungrounded conductors is 240 volts, while the voltage between each ungrounded conductor and the neutral is 120 volts. When the loads connected to the two ungrounded conductors are balanced, the current in the neutral conductor is minimized. However, when the loads are unbalanced, the neutral conductor carries the difference in current between the two ungrounded conductors. In the scenario described, the dishwasher and disposal are likely to have different current draws, especially when operating simultaneously. This can result in a significant current flow in the shared neutral conductor, potentially overloading it and causing it to overheat. Secondly, the use of 12/3 cable introduces another potential issue. While 12/3 cable is commonly used for multi-wire branch circuits, it is essential to ensure that the ampacity of the cable is sufficient for the expected load. The 12-gauge conductors in 12/3 cable typically have an ampacity of 20 amps, but this can vary depending on the insulation type and installation conditions. If the combined current draw of the dishwasher and disposal exceeds the ampacity of the 12/3 cable, the cable can overheat, potentially causing a fire. Thirdly, the fact that one circuit is switched while the other passes through raises concerns about the integrity of the neutral connection. In a multi-wire branch circuit, it is crucial that the neutral connection is continuous and uninterrupted. If the neutral connection is broken, the voltage on the two ungrounded conductors can become unbalanced, potentially damaging equipment connected to the circuit. To mitigate these potential problems, several steps should be taken. Firstly, the loads on the two ungrounded conductors should be balanced as much as possible. This can be achieved by ensuring that the dishwasher and disposal have similar current draws. Secondly, the ampacity of the 12/3 cable should be verified to ensure that it is sufficient for the expected load. If the ampacity is insufficient, the cable should be replaced with a larger gauge cable, or two separate 12/2 cables should be used, one for each appliance. Thirdly, the neutral connection should be carefully inspected to ensure that it is continuous and uninterrupted. All neutral connections should be made inside approved electrical boxes using appropriate wire connectors. Fourthly, ground fault circuit interrupters, or GFCIs, should be installed to protect against electrical shock. GFCIs are designed to detect even small amounts of current leakage and to trap the circuit breaker, preventing electrical shock. In summary, the configuration described presents several potential problems that warrant careful attention. By balancing the loads, verifying the ampacity of the cable, ensuring a continuous neutral connection, and installing GFCIs, the risks associated with this configuration can be minimized. It is always recommended to consult with a qualified electrician to ensure that electrical work is performed safely and in accordance with the National Electrical Code, or NEC.